entonces el título es en español, pero la charla va a ser en inglés, porque 8.8 va a devenir una conferencia más internacional cada año. Last year I had a talk on web security. This year I decided to change topic. So now I recently joined Trend Micro as a security researcher. And this is not really related to malware. It's a work that we did 6 months ago. So most of the things you see here are a result of what I did before joining Trend Micro. So what we want to talk is about what are the problems related with cloud computing. So that's basically the agenda for today. So we'll start introducing what is cloud and what are the security issues there. And I will then present a tool that we designed to test the security and privacy issues related with cloud computing. So what is cloud computing? It's a kind of a new buzzword. So everybody's talking about cloud. So cloud is cool, but what is cloud? So if we take Wikipedia, cloud is basically the delivery of computing as a service rather than a product. So before, you had like a laptop, server, and desktop providing something. Now all this information are providing using a service over the internet. So basically, the cloud is internet, and application such as can be, for example, the access to the mail is provided by the cloud. So Gmail is an example of application that use the cloud. Then you have a platform such as database. Database now can be bought from the internet, and you pay per use. And the same is with infrastructure. So using the cloud, you can easily rent, for example, a server or a network. So cloud, as you can see here, is a kind of old new concept. So parallel, distributed, and grid computing have been around for a long time. So, for example, scientists, government, and different organizations, such as military, were using distributed computing since the 80s. So it's nothing new, but as I was saying before, now everybody's talking about cloud. So what is the news here? What is new in the cloud? So cloud computing is now becoming a commodity, in the sense that most of us probably are already using the cloud, even if they are not aware of that. So, for example, who among you is not using a service like Gmail or Yahoo Mail? Any kind of mail server, the mail service that is that is hosted over the internet is exploiting this cloud capability. So why the cloud is a kind of commodity? Because it's very easy and fast to use. In fact, most of these services are a kind of ready to go, in the sense that you just pay for what you use, and it's very fast. So if you need a new email account, you just register and you have it. If you need a server, instead of installing a server in your home, you can easily rent a server. So you register, you pay with your credit card for 1 day of server computation, and you have it running, ready for you on the internet. So there are basically 3 different models of cloud services. So the first one is called software as a service. So here what is provided by the cloud is a software. So it can be, for example, software for customer relation management, such as Salesforce. Salesforce now is a new competitor of SAP, and is providing what SAP provided since 20 and more years in a kind of cloud fashion. Then there is another model that is called PaaS, that means platform as a service. So in this case, what is provided by the cloud is either a computing solution or a solution for development. So some examples here are Microsoft Azure and Google App Engine. And the third model is the model we will focus in this talk. It's called IaaS. So in the IaaS model, what is provided by the provider is either a computer that can be rented in form of a virtual server, for example, or storage, firewall, and even a full network with all the machine inside. So some example of IaaS providers are those one you see here. So probably the most famous one out there is Amazon. So Amazon is claiming to have like the biggest cloud infrastructure, and one of the services that they provide is called AC2. That means Elastic Cloud Computing. So what we basically offer is a virtualized server. So you have a server for Windows, server for Linux, and you can rent it. You can configure, for example, how much memory you want, how much hard disk you want, and based on the configuration you choose, you pay. There are then other competitors that are pretty famous, such as Rackspace, Terramark, Giant, and here you have a list of them, and based on how much they charge for a monthly of standard usage. Okay, so this is a screenshot of a Amazon AC2 portal. So Amazon give a possibility to user to use the service either using a portal or using an API from command line. So the portal is pretty easy to use. So what you have to do, you have to register. Then you have to select in which region you want to run your server. So there are 5 different regions. So the European main data center is in Ireland. Then when you select the region, what you have to do, you have to create a key pair. So it's basically the SSH key that you will use to access your server. And then you have to select which kind of server do you want to rent. So there are some of them are already let's say provided by Amazon itself, that are this one under the Quick Start tabs, while others that are the community MI are provided by the community. So what are these community MIs? So it's so what user can do, they can actually configure their own server image, and they can upload this image over the cloud, and then they can mark this image as public. At that point, all the other user can take this image and use it. So it's a kind of sharing community, such as can be, for example, BitTorrent. In BitTorrent is the same. I have my movie, I can put my movie over the cloud, and then everybody can download the movie. So here it's somehow similar. So Amazon allow everybody to upload the image and makes this image public. So what is the benefit here for Amazon is the fact that there are different companies that create some custom-based images, such as images with some pre-configured web application or with some pre-configured databases or some other application, and they upload it on the cloud. And then they make a kind of deal with Amazon, saying that every time somebody uses the image that I put on the cloud, I want to charge him. So I want to get something back from my customer. So when you have selected the image you want to use, the image get instantiated, and you have the state change to running. So this usually takes from 1 to 5 seconds for a Linux image, and from 1 to a couple of minutes for a Windows one. So it's pretty fast. And this is actually the business model around this Amazon AC2 service. So the idea is that you can go there, pick up one of the image, and you have it running in a couple of seconds. So there is no any more need of configuring the server in your data center and taking time to make sure that it works, installing the software. You just go there, you select one hosting that comes with an application you want to use, and you are ready to go. So when the instance is running, you have an IP that is assigned to the image. So there are basically 2 IPs. One is private IP address. So this allows to run multiple images in the cloud and share content between the image. And then there is a public DNS that is used to access the image from the outside, from the public IP. So that's very easy. So the problem here, what is it? Is that the trust model between the cloud provider and the user is well defined in the sense that Amazon is not going to hurt you. The problem is between the image provider and the user. So when you user go over the Amazon cloud and you're going to rent an image that is not yours, but is the image that somebody else provide. So the problem is this image like safe, so to use or not? So the main question here is, are there any threats associated with renting images from the public catalog of cloud service provider? And if there are problems there, which are these issues? So what we did, we ran a large-scale experiment over all the images provided by Amazon in his 4 data center. So we took all the public images available in Europe, in US, on East and West Coast, and in Asia. And we scanned them using a tool that did it like automatically. So what the tool did, it basically started with the first image, scan it to see if there are some issues, shut it down, take the second image, scan it, and so on. So it did all of this one for all my image, and it successfully scanned more than 5,000 of them, both Linux and Windows one. And this process took in total like 7 months using a single machine. So how we did it? We did it using developing a tool that is able to instantiate this image and test them in an automated fashion. So the tool is called SATANCLOUD. So the name comes from the fact that it's kind of satanic tool. So it's not a good tool, but it's a kind of black tool, evil tool. Cloud because it works on the cloud. And if you pronounce SATANCLOUD, is something similar with Santa Cloud. So I mean, I like the name, so that's how it's called. So the tool is composed by 3 main components. One is a robot. What the robot does, it takes a list of MIs to scan. So MIs means Amazon Machine Images. Okay? So you can give him a list of 10 or 100 MIs. What he will do, he will instantiate the first one, okay, using the API provided by Amazon. He will check that everything is fine, so the image is not broken, it runs. He checks the credential, okay, so he tries to log in using the SSH key that I specify when I instantiate the image. And then, if it works, it passes the control to 2 other components. So the first one is a remote scanner. What it does is scan the image from a kind of a remote point of view. So as I told you before, each image has a public IP address, so I scan it remotely. And the second component is a local scanner. So what it does, it uploads like a test suite with a configuration for a scan of a vulnerability, and it will execute this test suite remotely on the MIs. This will take a couple of minutes. When it's finished, it will get back with the result, and then it will store the result in a database for further analysis. So the test suite is a self-extracting archive. Okay, so we have a test suite for Linux and a test suite for Windows. So the test suite for Linux is a mix of shell and Python script, while for that one for Windows is a mix of BHT, batch files. So what the test suite does, it runs different tests. So there are some tests that are you can see here in the type category are general tests. So they retrieve information on the type of operating system that is installed, if there are some emails left over on the machine, which are the processes that are running, the modules that have been installed, the packages, and so on. So some tests works only for Linux, some works for both, and some works only for Windows. So there are 4 different types of tests So the first one is general, I told you. The second one is network related. So what this test does, they check whatever the image that you're renting is connecting to, for example, a CNC, or if it's running, for example, a keylogger that is data leaking some information. And then there are two other main groups of tests. The first one are related to privacy issues, and the second one to security issues. So the privacy issues, we check whatever the image that you rent comes with, for example, some keys that have been forgotten by the guy that uploaded the image, or some private information that have been forgotten by the publisher of the image. While in the security test, there are tests like for rootkit, for malware, for process that are running and are hidden from the process list, and so on. So that's the setup. So just to summarize, what we did, we took the most used and popular cloud provider, that is Amazon. Okay. Then we developed like a tool that we use to test in an automated way all the public image that you can rent from the Amazon cloud. And the tool does different tests. Some are generic, some are related to the privacy, to possible privacy issues, and some other to security issues. And we ran this experiment using a single machine, like this one, for 7 months. Then we collect the result, and we analyze them. So now I'm going to show you some of the findings we have from this research. So the findings are divided in two categories, those are related to security and those are related to privacy. So starting from the first one. So the first question is, are this image up to date? Okay, because the business model here of the cloud is that you don't need to invest time in configuring the image. That's why you go there and you rent it. Okay, otherwise I could use my own image, but I don't want to do it. I want to go there, I want to pay. Okay, I pay for 2 weeks. And in these 2 weeks, I want an image that I'm ready to go. I don't want to buy an image and then invest 2 days for patching it. Otherwise, I'm losing money. Okay. So what we did, we tested this image using Nessus. Okay. So we configure Nessus to log into the image and to run the security test from the image itself to prevent to have a high rate of false positives. So we limit the analysis to critical vulnerability always. So the different vulnerability in Nessus have a level of risk that range from 0 to 3. So we just select the test for vulnerability that is marked as 3. So those that are considered critical. Critical means that if there is one of that vulnerability, an attacker may easily get access to your machine. So the results are this one. This is for Linux. So this is for Windows. So if you can see here on Linux, you have a bunch of MIs. No, this is Linux, sorry. This is Windows. Why I know it? Because in Windows MIs are much more buggy than the other one. So in Windows, you have more than 20 and 25 MIs that have 50 critical vulnerabilities. So if you rent an image that has 50 critical vulnerability and there's a public IP, it means that probably if you don't patch it within the first hour, you will get exploited by some malware easily. So in Linux it's not so critical as Windows, but still there are more than 100 machines that have 1, 2, 3, up to 10 critical vulnerabilities. What is more, so this to summarize, so we have 98% of Windows and more than half of the Linux machine that have critical vulnerabilities. And even there are machines that have vulnerabilities that are more than 2 years old, 3 years old, and in average you have 46 critical vulnerability for Windows machine and 11 for Linux. That's really a lot. What is cool is that I found 87 Debian MIs that come with a notorious SSH OpenSSL vulnerability disclosed in May 2008. That was, I don't know if you remember, it was a vulnerability in which the key of SSH was not 100% randomly generated, so it was possible to guess the key and get access to machine protected by the key using SSH. So we show that if you rent image over the cloud, you want to make sure that these images are okay, are up to date, and are well configured, because most of these vulnerabilities are not only related to the fact that the software is old, but the fact that the software is badly configured. For example, that FTP allows, I don't know, anonymous access, something like this. Or maybe that there are some demo like air logging that nobody uses anymore that are running. What we did then, we look if there were machines coming with malware installed, because since these are public image, okay, I may, for example, create an image with tons of malware, upload the image over the cloud, and wait until one of my victims rent the image. So what we did, we use Clamavis, that is an open source antivirus tool that runs both on Windows and Linux. So this is exactly what we need. So the antivirus contains more than 800,000 signatures. We ran it, and we discovered 2 infected MIs. So the first one was hosting a keylogger, one Trojan spyware that was doing keylogging, process monitor, and data leakage. And the second one was actually browser spyware for Internet Explorer. What's interesting of these two is that I ran the analysis, okay, and after like 1 month I checked the log. So I saw that there were these 2 MIs with malwares installed. So the first one, what I did, I then start manually the first one. And in the first one, I verified that actually there were malware installed there. Okay. Instead, in the second one, I couldn't find it. So in this case, there are 2 possibilities. Either is a false positive by the antivirus, it can be. The second one, that is probably what I think the most probable possibility, is the fact that the machine have been like exploited by a malware when it was running, because this test of Clamavis takes, I don't know if I have a result here. No, it takes about half an hour, because there are plenty of files to be tested. And in this half an hour, this machine is running without firewall. Okay? And if this machine is one of these one that has 50 vulnerabilities, it's pretty likely that it will get like exploited automatically by some malware running over the internet. Okay, the next step is this one. So the other things that we decided to look at is if some of these MIs connect to some host, okay? Because I rent a server, okay? I'm expecting that when I rent this server, there is no traffic going out from the machine, okay? Because it's new, okay? It's like when I buy a new telephone, I'm expecting this telephone is not generating traffic. There is nothing installed, okay? So using netstat and TCP dump, we basically monitor whatever there are some connection. And at the end, it came out that there are plenty of outgoing connection. And it's very hard to evaluate each of them in automated fashion. I have to say that most of them, probably the majority, are related to software either software that is installed that for some reason connect to outside, or some other software that is trying to update part of a system, or fetching the new, like, for example, if you take a Fedora will automatically fetch the new update. But what is cool is that we found different MIs that had Linux NG installed. So I don't know what is it. I don't know if you know what is it. Is a daemon for logging. It's a standard daemon provided by a lot of Linux distribution. What is cool of this NG, new generation logging facility, is that allow to export the log remotely. So if you see the snippet of code there, what we found is something like this. So we found like a bunch of MIs where all the log information were sent to an IP hosted in Russia over port 540, and this one was controlled by the attacker. So that means that you go there over the cloud, you rent an image, and then as soon as you log in, already the first command is sent out to the attacker. So basically there is the functionality of leaking all the information that you are entering into the machine. Next, we look into like either password, okay, that have been left on the machine that you rent, or public SSH keys. Why? Because when you rent this image when you publish an image over the cloud and you want to access this image, you have to provide a key. So what if the user that published the image forgot to delete his public key? What happens is that then, if you rent the image, the guy that published this image, he has the private key to log into. So that means that this leftover credential can turn the image, into backdoor. So it means that if you see here, there are 20% of MIs with leftover credential, either password or SSH public keys. That means that 1 out of 5 of the image that you rent give a possibility to the attacker to log into your machine. And if you look here, there are 900 over 185 that allow the attacker to log as a super user. So that means that either the user is a kind of pseudo user or is root. So this is very scaring. And so when I found this, I contacted Amazon, and what they did, they immediately marked all these list of 21% out of 5,000, that means 1,200 images that I found with this problem. They mark as private. That means they prevent the user to rent them. And they sent an email to all the customers that were running the image saying, hey, check the password file, because a bunch of these one have like password enable or public SSH key installed into the machine. So this brings us to this question. So suppose you have an attacker that on purpose create an image, well configured, and promote this image over the cloud. Okay, so put the image over the cloud and basically wait until somebody rents the image. And suppose the attacker leave an SSH key in the image, or an enable, or a user with a password. Okay, then I am a victim. Okay, I rent this image, and I'm not aware of this fact. So the question is how the attacker can know on which IP the image is running. So there are two possibilities. Either in the image there is a system that ping back. So they send to the attacker information saying, hello, I'm here, I'm running, that's my IP. And so the attacker can then connect to the machine. Or there should be a way to kind of match the image with IP space to determine which IP has the image. So what we did, we scanned all the Amazon IP range, and we found that there were 650,000 IPs online. That is, if I'm not, no, actually no, I'm wrong. So we scanned all the Amazon IP range, that is a total of 650,000 IPs. Okay, and we collect information for 233,000 instances. That means that out of all the Amazon IP range, there are 1/3 of a machine, so 1/3 of the space is busy. Okay. Out of these 233, here you have the numbers on how many instances are running SSH, how many instances are running some kind of service that can be mail server, a web server, FTP server, whatever you want, and some other are running a web application. So what I did, I compare the result given from the type of SSH service we're running and the key of the SSH server daemon with the information of that I knew a priori from all the 5,000 MIs that I scanned. I don't know if you get it. So what I did, I took all the MIs of Amazon, I scanned them, okay, and here what I did, I dump information on the software that is installed, the SSH key, the version of a different service, and then I scan all the space mapped to Amazon, and then I compare. So there are 3 different techniques for doing this matching. The first one, that is the SSH method, is 100% precise. And this works like that. So you scan an IP, you check the SSH key of SSH server, and you compare the key. Okay? And in this case, we have 1.65% perfect match. That's about 2,000. So for 2,000 instance, I was able to find out the IP mapped to the instance. So that means that it's possible for an attacker that configure a malicious image to find out which is the IP of this image. Of course, if we enlarge the candidate to a set of possible 10 candidates or 50, we have a larger, higher number. So it means that for an MI, I can tell you, no, for a given IP, I can tell you the IP of this machine that is running is either one of these 10 MIs or 50 MIs. It's not so bad. Then the other 2 techniques that are the service one and the web one. The first one, check for the service running of a machine, and the other one for the web application. Okay, I have a couple of more slides to show you. So the first part of the talk here was related to the security issues. So are the issues related to the user that rent the image. To see what are the problem that I'm a user when I rent this image. What are the security risks? This is the other way around. Okay, so I am one of the company that provide image over the cloud because I want. That's my business. Okay, I'm a company that provide any kind of image, like image with some special software for CAD computation, some other image for software for mathematical computation, and I put it on the cloud, and they want then the user use this image, and then I get charged. Okay, it's my business. So what are the privacy risks to me that I publish image over the cloud? One risk is this one, that when I publish the image, I forgot some keys in there. Okay? So which kind of keys? I can forgot, for example, private SSH keys, okay, or Amazon AVS keys. So what we did when I scanned these 5,000 MIs, I also check whatever these MIs come with some of these keys. What I found out, I found that I found 56 private SSH keys used to log in to our machine, and out of these 56, 54 were not protected with a passphrase. Okay, this is it's very severe in the sense that if you think of this, I can easily take these private SSH keys, then I can check in the logs of the machine and try to guess from where the user that published the image connect from. And then I can map the SSH key to the user. And I mean, bad problem, no? Even worse, it's about this AVS API keys. So what is this? As I told you before, here, when you use this Amazon EC2 service, where is it? This one. You can use either the web interface, cool, or you can do it from a command line, okay? So my tool was running from a command line because it's kind of automated tool. To run, you have to create this Amazon Web Service API keys. So these are kind of something like SSH keys. So basically, it allows the user to authenticate. And this one does not have password. So I don't know why, but the guy that designed Amazon, that designed this protocol, they didn't add the passphrase, the possibility to add a passphrase to this key. So I was able to retrieve 67 of these keys. And with these keys, I can easily start images on the cloud, or rent 1 terabyte of space, or rent 50 servers to the expense of somebody else. You see the problem here? You see the privacy risk here? That's a privacy risk that there are a lot of images on the cloud that have interesting things on it. One is this. This is another one. Shell history. So you know, both in Windows and both in Windows, when you type command from shell, the command gets recorded into the history, no? So either you clean the history or you direct the history to dev null, but if you don't do it, the commands are there. And there are a lot of names that when they specify a command, they also specify from a command line username and password. Something like this. MySQL -u user -p password -h host. So it's very fast, you know, this command, because you don't have to type the password, but it's already there, no? The problem is the same problem you have server side when you send like username and password using a GET. You know why there is a GET and the POST? The fact that when you want to post data such as username and password that is considered sensitive data, it's better to use a POST rather than a GET, because the get log into the logs of a web application. So Apache logs in file called access log all the get. Here it's something similar. If you specify username and password from command line, it will get recorded into your hard drive. So if me, that I'm attacker, I rent the image and I check the logs, I can easily get access to what? Like Amazon, this is a kind of username and password for Amazon RDS system, dynamic DNS, database monitoring, MySQL, web application, VNC, and total. So I retrieve like 74 credentials. 54 were related to program installed on the machine, and 20 to external machine, not completely unrelated to the image that I rent. So the last question is, so if I delete my data, then I'm fine. Okay, so I want to publish this nice computer of Claudio over the network. So I do like a DD of the hard drive, I build an ISO, okay, then I clean all the sensitive information. So I do it before. I take this one, I remove all sensitive information, I do a DD, I create an ISO, and then I upload it over the cloud. I'm fine? Not really. So Amazon, in Amazon there are 4 different methods to bundle, that's the term, to bundle like a machine and put it over the cloud, okay? Some of them work at file system level and some work at block level. So the difference here is that in a file system level, if I delete something and then I try to copy, it's deleted, it's impossible, okay? Instead, in the block level, if I delete something but I don't wipe the space, so I don't overwrite like the space, the free space, when I do this kind of copy at block level, the file gets copied. So that means that if you use a tool like for undelete a file, I think most of them, like 20 years ago when there was DOS, they were using this undelete utility, because you do del, name the file, oops, I deleted my important file, I have to recover it. Yes, there is the undelete tool. Undelete, name the file is back. So it is the same. So what we did, we select randomly 1,000 Linux MIs in all the different regions, and we used a tool called Undelete that allowed to automatically undelete like data from extended file system. So we were able to undelete 28 gigabytes of data. So that means we recover data for 90% of MIs, from 6 to 400,000 files per MI. So we undelete data for home files, images, Microsoft Office documents, Amazon AVS certificate and access key, those one I explained you before, that for a total of more than 200 of these keys, SSH private keys, PGP private keys, password file, and so on. And among this one, even a private SSH key from an official Amazon image. Because there are images provided by the community that are the public image, and then images that are provided by Amazon itself. This one. Up. Here. You see the Amazon logo? This is an image provided by Amazon, okay? They even have a star here saying, this is cool, this is safe. I ran to one of this one, I ran the tool, and I found a key of one of the engineer of Amazon. Okay, where we are. That's a screenshot of a similar tool for Windows that is called WinUndelete. So this is a screenshot where the tool basically recovered 900 deleted files. So I have to say that during all this experiment, we actively collaborate with Amazon. So most of the time I found vulnerabilities in application or infrastructures. Most of the time I didn't get an answer. You know, like you write, you say, hey, I found a bug, they even don't answer you. Except Google, that have a team that works pretty well. So every time I found a problem in Google, they answer fastly. Facebook as well. Very rapidly, they answer you pretty fastly. PayPal as well. But in most of our cases, zero. Amazon, they were number one. So they really answer like the same day. So when I informed them about the password and public key left over, I told you before, they send a bulletin online. They put a bulletin online. They send an email to all the users. Cool. About the leftover data, so the fact that a lot of images come with a private SSH key left over, or they answer like, we release within 5 days a tutorial to help customers to share public image in a secure manner. Like, guys, if you share an image over a cloud, maybe you want to delete your personal information and even wipe the free space. And that's the third point. So when I told them about this wipe, they verify our findings immediately, and they also examine all the MIs. So to conclude, so why we did this is because it's something new, and I didn't like the fact that with this cloud you can easily go there, rent a server, and run it. You know, it's not so easy. In fact, when you run one of these images, you want to make sure to do all this checklist. So you want to immediately upload the software, and this is something you have to take care of, and it takes time. You have to regenerate the SSH host key to prevent that the attacker find out which is the IP of your MI. You want to delete any user password and SSH key. You want to check the configuration file of the service to make sure that it works, that they are okay. And this takes a lot of time, because you remember that you're using a machine that is configured by somebody else. So you don't know how the web server is configured, how all the different services are configured. You want to check for suspicious connection. You want to check if there is malware installed. You want to check if all the processes that are running are safe. It's a lot of work. So it may be easier to prepare your own image. You prepare your own image, you upload the image over the cloud, you mark the image as private, and that's me. It's the image of Marco. I'm the only one using it. So these are the reference. So we basically build a paper out of it that we present in a conference. So I'm open to question, either now or if you don't have time, I will be around during these days. So thanks a lot for your attention.
Aló, ¿alguien tiene alguna pregunta para Marco? ¿No? ¿Sí? Acá.
Marcos,
No te entiendo, la herramienta.
¿En qué está hecha la herramienta?
¿Qué es la herramienta?
La tool.
Ah, ok, la herramienta, sì. Il tool, la herramienta è in Python, e la test suite, che è la suite che io uploado sul server, è un misto di Python Bash per Linux e batch file per Windows. Sì.
¿Alguien más? Acá.
Hi, Marco. Great presentation. Question: You say you crawl all the public IPs you find from Amazon?
Yeah.
Related to those, so they were randomly generated, or you find an automated way to discover the new IPs? Because actually what we're seeing right now is that there are a lot of automated tools that probably might be the algorithm you use for crawling all those IPs.
You mean how do you get this list of 5,000 MIs?
Yep.
There is basically the API from Amazon.
Oh.
So you have to specify which region. You have to specify which characteristic. So you have to say, I want the public one. I want the public one that I don't have to pay for. Okay, because there are private that are that one of the users. Public are that one that are in public catalog. And in the public there are the free one, and that one that you have to pay. Okay, and so the free one, you have to say, give me all. The Linux one and the Windows, and you have a list. So I mean, it's very easy.
Oh, okay. Yeah, that was amused me, because actually it's like I guess that wasn't the very first months of this year that a guy got to hack like 3,000 web pages. Probably he was doing kind of the same.
Wow.
I know. Okay.
¿Alguien más? ¿No? Bueno, le damos las gracias a Marco por su presentación.